Alright, this is a video we're going to use we're using easy calculation to be able to basically test the significance, define, computer correlation coefficient, find the p-value, and then explain that type of relationship. I've already done the calculations. This is a pretty lengthy problem, and I only can record for about 15 minutes and upload to YouTube. So if you need to watch it several times or ask questions, please do. I'm going to use a problem straight from your homework assignment. So here we go. Let's go ahead and get started. Let's take a look and just kind of see what's about to happen. So we're going to test the significance of a correlation coefficient, and our actual level of significance may change, and I'll talk about that as we work the problem. Our particular problem that we test the significance on was basically at a significant level of 0.1. Okay, so kind of get an idea. It's just a little bit stronger test, I guess. So let's see. Let's jump into the problem and let's take a look at what we're going to see. Okay, so we're basically, I've already worked the problem now, I apologize. We started the problem off, and we hadn't really talked about hypothesis, so I'm kind of giving you a crash course on hypothesis testing at the same time. When we have hypothesis testing with, a situation like this, we have to establish what our goals are going to be. So we have two things. We have this H naught and this H1. And you'll notice here that with H naught and H1, that basically, let me make this a little bit bigger so we can see it. H naught is called your null hypothesis, and there, if you have your null hypothesis, it means there's no correlation between the variables. So what we're looking for here is a positive correlation or negative correlation. If you watched that previous video, you saw that we're looking for a correlation that's close to the number 1 or to negative 1. So if you have a positive slope on the line, it will be a positive slope, so therefore it would be a positive correlation close to 1. And if you had a negative correlation, it would have a negative slope and a negative correlation close to negative 1. But however, if we find that we do, so in this case here, it's like saying there's no correlation. But for the alternate hypothesis, we're going to find some significant relationships. So we start off by saying, nope, my null hypothesis, my bottom hypothesis is no correlation. The alternative to that would be there is a significant correlation. And so we have some tests that we're going to use to help us establish if we're going to accept or reject, whether we find out there's significance or a lack of significance. And that's when we reject or accept. Okay, so let's take a look at that and kind of move forward. So in this case here, we're always going to put our null hypothesis equal to 0, our alternative not equal to 0. Using your ordered pairs here, go through and take a look at the scatter plots they provide you and eliminate the scatter plots that don't have the ordered pairs that fit. Choose the correct scatter plot. In this case here, my answer was B. Now we compute our correlation coefficient. We're going to use Easy Calculator to do this. So let's go ahead and take a look at Easy Calculator. So we're going to come here. I've provided the link to the Easy Calculator for this one for you on the suggested homework, but we're doing correlation coefficient. Okay, and this is a new run through, so at this point here, there are, if I go back to the sheet and show you here for a second, give me 1 second there, excuse me. There are 8 ordered pairs. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to need to, when I do Easy Calculator, I'm going to need to make this have 8 spots. 1, 2, 3. So now I have 8 locations. Okay, so I've already done this calculation, so basically now you would type those numbers in. I'll just type in a few so you can see. Hit tab, 521, tab, 17, tab, 84.8, tab, and you would just keep on going. Once you get them all in, you'd hit calculate. But I already have that calculated, so let's go ahead and go to that screen. Okay, so when I found those calculations, where is it? Here it is. I got these results. Okay, so it told me that my correlation coefficient is negative 0.6831 da 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 da. I'm going to ask that for the sake of these problems right now, for calculation purposes, that you round your answers all the time to 6 decimal places when you're doing your calculations. But now we have a correlation coefficient. That's what the next step said in connect. So we go ahead and go into connect, and in connect we enter that correlation coefficient. Okay. You'll notice right here in that answer blank it says round your answer to 3 decimal places. So you take that correlation coefficient you had and you round it to 3 decimal places, and there you go. Part 4 says find the p-value, and we're going to use the p-value to test it. And so what the p-value, and I kind of explain this and they explain it and solve it, but I'll explain it here in a minute. So now to find the p-value, we've got to do a couple things. So let's go ahead and go back to Easy Calculator so you can kind of see what we're going to do. In Easy Calculator, there's actually a calculator called probability value for the t-test, which is the p-value. Probability value, the p-value for the t-test. So click on that guy. Once again, that link is provided in the suggested homework. Now you'll notice here it asks for a t-value. Well, you've got to calculate that t-value. You're not as fortunate if you're using your graphing calculator, then you can just plug these in real easily. So in this case right here, we've got to calculate the t-value. So let's go take a look at how we do that. Alright, so to find the t-value, to be able to do the probability value for the t-test, we actually have to use this little formula right here. So we're going to take that little formula and we're going to plug in what we know. So we know that our correlation coefficient is rounded to 6 decimal places. That's very important because otherwise if we round it smaller, our numbers will be off when we put them into connect. So we go through this little process here, plug our numbers in. You have the beauty of being on YouTube. You can hit pause and take a look at where my numbers came from. N is the number of items in my list. There are 8 ordered pairs, so that's where I got n minus 2. Degrees of freedom is also n minus 2, and we use that degrees of freedom later when we put things back into Easy Calculator. We plug in our numbers, the 6 decimal places. We go through step by step. 8 minus 2 is 6. 1 minus the square of that number is 5.53313. 6 divided by that is 11.2. Round to 6 decimal places. Again, I'm keeping that 6 decimal places. The square root of that number is 3.354,166. 6 decimal places. I multiply those two numbers together and I get a t-value with 6 decimal places. So I took that t-value with 6 decimal places. I went back to my Easy Calculator and I plug it in. Now you'll notice you'll type the negative, it goes away. Don't worry about that. 2.291382 degrees of freedom. Remember there's 8 objects, take away 2 of them. I have 6. I calculate. We go back now so you can see that's where I got those numbers. So I go back, you can see here are my results. Excuse me, right here are my results. My t-value with the degrees of freedom of 6 gives me these values right here. So now I can go back to connect, and that's how I got that solution rounded to 4 decimal places. That's my p-value. Now what does my p-value tell me? My p-value tells me this. It basically says, and let me erase that right there so we can see that a little bit better. My p-value is essentially saying to me that if my p-value is less than my starting significance level, then I reject the null hypothesis. If my p-value is greater than my starting significance value, then I do not reject the null hypothesis. So in this case right here, my p-value is 0.06. So what we're looking at is this. We started off with a significance value of 0.1. My p-value is 0.0618. Therefore, my significant value is greater than my p-value, and in that case right there, I'm going to reject the null hypothesis. Okay, so now we got one more little thing here. When rejecting the null hypothesis, you find out that there is significance in your claim. When you reject the null hypothesis, there is significance in your claim. If you accept your null hypothesis, then there's not enough evidence to support. So in this case right here, we go back to connect, and what we find out here in connect is that because of the fact that my p-value was less than my significant value, right here, this guy, and because my correlation coefficient is pretty large, it's pretty close to -1. I mean, if you think about this, my p-value is, my correlation coefficient is basically -0.683, and when you compare that to -1, those are pretty close numbers. So remember that we're looking for correlations that are close to -1 or +1, because the stronger the correlation, the larger it is. The closer it is to -1 or the closer it is to +1. So this has a pretty strong correlation, and that correlation is an indication in that the tax in cents per gallon and the amount of usage. So in this case right here, the higher the tax, the lower the usage, and that's a negative correlation. As the tax went up, the usage went down. All right, and that's what we're trying to establish here with this particular problem of correlation, and whether or not we can, see a significance in its correlation. All right, please let me know if you have any questions.